Hello, welcome back. We will be continuing in section 7.6, solving exponential equations. Like we talked about last time, we are using the one-to-one property of exponents to be able to solve these exponential equations. In order to do that, we need to get the bases to be the same. We see that the base on problem 4 on the left side is 16, and on the right side is 8. So let's go ahead and do a prime factorization for both of those numbers to see what we come up with. So if I have 16, 4 times 4 is 16, and then 4 can be written as 2 times 2, and the other 4 as 2 times 2. Then 8 is 2 times 4, 2 is prime, but 4 is 2 times 2. Now we have those as all prime numbers. So I can see that 16 is 2 times 2 times 2 times 2, or I can write that as 2 to the 4th power. And 8 can be written as 2 times 2 times 2, or 2 to the 3rd power. All right, now we can't forget about the other part of our exponent here. So I have a 4 on my exponent, but I need to multiply it by that 2x plus 1 that's also in the exponent. And on the right side, that 3 needs to be multiplied by the 3x minus 2. And then these are equal to each other. So remember, since they're equal to each other, we can use that one-to-one property of exponents. And it says when the bases are the same, we can set the exponents equal to each other and then solve for x. So let's do that. So we're going to just take the exponent part and see what we come up with here. So I'm going to have 4 times 2x plus 1 equals 3 times 3x minus 2. Let's use the distributive property here. So distributing the 4 through, we'll get 4 times 2x is 8x. 4 times 1 is 4 equals, now let's distribute the 3 through. 3 times 3x is 9x. And 3 times negative 2 is negative 6. And now we need to just solve for x. I'm going to choose to subtract my 8x over to the right side and add my 6 over to the left side. When I do that, I see that I'm left with 10 equals x. And that would be my answer. Again, you can always check to make sure that you have it correct by going back to the original problem and substituting 10 in place of x and see if you get the same answer on both sides so that it is a true statement. All right, let's look at number 5. So number 5 looks a little bit different than ones that we have started off with because we have a lot of other things here. We've got 4 times 3 to the x power minus 18 equals 90. But remember, we want to get it to look like a base raised to a power equals that same base raised to a power. So what I need to do on this one is I need to isolate that 3 to the x power. So let's start by adding 18 to the other side so that we can start isolating that. So when I do that, I get 4 times 3 to the x power equals 108. Now, to get 3 to the x power isolated, let's divide both sides by 4. So that gives me 3 to the x power equals 27. All right, now that's starting to look like what we've had before. And now I need to write that 27 so that it is 3 to the something power. Again, if you're not sure what that is, you can always do some prime factorization, factor tree over here. So we know 3 times 9 is 27, and 3 times 3 is 9. So 3 times 3 times 3 is 27. So I'll rewrite this as 3 to the x power equals 3 to the third power. Now that my bases are the same, I can set those exponents equal to each other. And when I do that, I see that x equals 3. And that is my solution. Again, if I wanted to check this, I could do that by going back to the original equation and putting 3 in place of x. Well, let's do that over here. So I have 4 times 3 to the third power minus 18 equals 90. So follow the order of operations. 3 to the third power is 27, so I'll have 4 times 27 minus 18. We want to see, does that equal 90? Well, 4 times 27 is 108. And if I subtract 18 from that, I get 90. So 90 equals 90. Yep, that means I have that solution correct. I hope that helps you understand better how to solve these exponential equations.